This is the review for the Unit 1, Topic 4, Formative 3 test in Honors Geometry. So for question 1, you're given two triangles and you need to find the measure of the missing angle. You need to find x. So what we have to use is the Triangle Sum Theorem, which tells us that the angles of a triangle add up to 180. The first thing for A that we also need to know is that this symbol right here means that that is a right angle, which means that it adds up to 90 degrees. So we're going to have 90 degrees plus 60 plus x equals 180. Well, 90 plus 60 is 150. 150 plus x equals 180. And to get x by itself, we're going to subtract 150 on both sides and get x equals 30. So we know the measure of the missing angle is going to be 30 degrees. For part B, what we're given is an isosceles triangle, which means that the opposite angle of each congruent side, so this side and its opposite angle, and this side and its opposite angle must be the same. So we know x plus 30 is going to equal 180. Well, x plus x is 2x, so 2x plus 30 equals 180. I'm going to subtract 30 on both sides and get 2x equals 150. So then I need to divide by 2 and get x equals 75 degrees. So I know that each angle of this triangle is going to be 75 degrees. For question number 2, we're asked to solve for x. And now what we're given is triangles with unknown degrees. Again, I'm going to use the Triangle Sum Theorem, which means that each of my angles added together is going to be 180. So I have x plus 21 plus x plus 23 plus x plus 61, and that's going to equal 180. Well, x plus x plus x is 3x, and 21 plus 23 plus 61 is 105. So 3x plus 105 equals 180. I'm going to subtract 105 on both sides and get 3x equals 75, and divide by 3, and x equals 25. So really it's going to be 25 degrees, and then I can find each individual angle by plugging in 25 for x. For B, we've got x plus 2x plus x minus 16, and that's going to equal 180. Well, x plus 2x plus x is 4x, minus 16 equals 180. So I'm going to add 16 on both sides this time because it's negative 16, and I'm going to get 4x equals 196. Divide both sides by 4, and x is going to equal 49 degrees. For question number 3, we're asked to solve for x and y. Let's start with x. What we can see is that we're given this angle and we're given this angle. We don't know what this third angle is, but we know that the three angles added together equals 180. However, these lines here tell me that this side is congruent to this side, which means it's an isosceles triangle, which means that its opposite angles are congruent. So we know that this angle is also going to be 4x plus 12. So we're going to have 2x minus 4 plus 4x plus 12 plus 4x plus 12, and that's going to equal 180 degrees. Well, 2x plus 4x is 10x, and negative 4 plus 12 is 20. So this simplifies to 10x plus 20, and that's going to equal 180. Subtract 20 on both sides, and we get 10x equals 160. And divide both sides by 10, and we find out that x equals 16. So we know x is going to equal 16. The next thing we have to do is find y. The information that we're given is that this side is congruent to this side, which means 22 is going to equal 3y plus 7. So 22 equals 3y plus 7, and I'm going to solve for y. So I'm going to subtract 7 on both sides and get 15 equals 3y. Divide both sides by 3, and 5 is going to equal y. So we know y equals 5. For question number 4, we're asked to do a proof. What we're told is that line AC right here is parallel to line DE. So all those angle relationships that we know will be prove that angles are congruent because we know that this line is parallel to this line. What we're going to try to find and prove is that angle BFC, so this angle right here, is congruent to angle FGE, which is right here. Now notice, I know some of you are thinking, oh, that's easy, I can do it in one step, but they've set it up for you, and they want you to do it in 4 steps. So keep in mind, we're not going to just do it with corresponding angles. So the first thing is we have this unknown, and the reason is given. Well, there's only one given here, so we know that it's going to be line AC is parallel to line DE, and that reason is given. Next thing they tell us is that angle BFC, so this angle right here, is congruent to angle DGH. That's that angle right there. And the reason is, while those angles are alternate exterior angles, so we can say the definition of alternate exterior angles. All right, after that, it says angle DGH, so that's the angle we just talked about right here, is congruent to angle FGE, which is this angle right there. And the reason for that is the definition of vertical angles. So finally, we know that we're using the transitive property to prove angle BFC is congruent to angle FGE. And what we see is that angle BFC is congruent to angle DGH, and angle DGH is congruent to angle FGE. So by the transitive property, angle BFC must be congruent to angle FGE. So angle BFC is congruent to angle FGE, and that finishes our proof. For question number 5, we're given the fact that side AB is parallel to side CD. So we know AB is parallel to CD, and we know that AD is parallel to CB. So we're given that information, and we're asked to prove that AC, which is going to be this diagonal, is congruent to BD, which is this diagonal. So I'm just going to draw in. We're trying to prove that that is congruent to that. This is going to be a pretty basic proof. Remember, my setup always starts with a statement and my reasons. You can pluralize that if you want, it doesn't matter. And I'm going to start with my given. Since both of my givens are related to each other, I can put them in the same step, or I can put them in different steps, like step 1 and step 2. I'll just put them in the same step. AB is parallel to CD, AD is parallel to CB. And the reason for that is because it's given. Next thing I know is that ABCD is a parallelogram. And I know this because of the definition of a parallelogram, which says that I have two sets of opposite sides which are parallel. So I know ABCD is a parallelogram. Oops, not two. Sorry, not three. Two, my reason why is from the definition of a parallelogram. And if you want to say the reason is opposite sides, there's, two pairs of opposite sides in a parallelogram are parallel, that's fine, but you can just simplify it to the definition of a parallelogram. Finally, because we've proven that it's a parallelogram, certain things we know are that opposite sides are congruent, opposite angles are congruent, and we know that the diagonals are congruent. Since that's what we're trying to prove, we're just going to go straight to that and say AC is congruent to BD, and the reason is definition of a parallelogram again. You won't see many proofs like this, especially on your tests that are this basic, but at least it covers the fact that you have to know what a parallelogram is and its properties in order to do this proof. Moving on to number 6. First of all, I'm going to do my setup. We have statement and reason. And I'm going to always look and try to do the proof without writing it down just yet so that I have a game plan. It's like a graphic organizer to organize your thoughts before an essay. You really want to look at the proof holistically and kind of figure out what you're going to do to prove it before you start writing down all of your stuff. So I know that DB is the angle bisector of ABC. Well, since it's the angle bisector, I know that this angle is going to be congruent to that angle. I'm also told that AB is congruent to BC. So I know that AB is going to be congruent to BC. Well, I'm trying to prove that AD is congruent to CD. So if I could prove that this triangle is congruent to this triangle, then I can prove that through CPCTC. So right now I have a side and an angle, and I know through the reflexive property that that's going to be congruent. So that's how I'm going to prove my two triangles congruent. So the first thing I'll start with is DB is the angle bisector of angle ABC. And the reason for that is it's given. Now logically, I'm going to use that statement and write out what else I know because of it. And what I know is that angle ABD is congruent to angle CBD. Make sure that your corresponding parts always line up. So here I'm starting from angle A and going on the side of 1 to B where I know it's got a mark, C to B. And the reason for this is the definition of an angle bisector. So now I've proven that this angle is congruent to this one. Next thing I know is that AB is congruent to BC, and that's because it's given. Now I need my last side, which is going to be BD is congruent to BD, And that is because of the reflexive property. So, because of that, triangle ABD is congruent to triangle CBD. Remember, keep your corresponding parts together. And this is going to be because of the side angle side theorem. Because we've proven the triangles are congruent, we can prove that AD is congruent to CD because of CPCTC, corresponding parts of congruent triangles are congruent. For number 7, we're given a set of lines, and we are told that line AD is parallel to line EH, and angle BCG is congruent. So this angle right there is congruent to GFB. This angle right there. So we are trying to prove that BC is congruent to GF. So as per usual, I'm going to start with my statement heading and my reason. Now I'm going to tell you right now, you could go through this proof and prove that quadrilateral BCGF is a parallelogram and prove this. I'm not going to do that because I know that this is about angle relationships, but I'm going to tell you right now that if you did it that way, that's not wrong. So anyways, starting with, I'm going to look at this proof and come up with a game plan. I know that this is parallel to this, so I know that my angle relationships exist. For instance, alternate interior angles are congruent. I know that this angle is congruent to this one, and I'm trying to prove that BC is congruent to GF. So what I see right now are two triangles, so I'm going to try to prove that those two triangles are congruent. What I also know, because these lines are parallel, I know, for instance, that this angle is going to be congruent to that angle because of alternate interior angles, and I know that side's going to be congruent to itself because of the reflexive property, and there I suddenly have angle, angle, side, and so I can prove that the two triangles are congruent. So the first thing I'm going to start out with is saying that line AD is parallel to line EH, because I can't do any of my angle relationships without this, and this is given. Next I'll do angle CBG, again keep your corresponding parts together, is congruent to FGB. So C, which is the one angle, CBG, so I'm going one angle, two angle, nothing. I'm just looking at my marks. CBG is congruent to F1, 2, nothing, FGB. And this is because of the definition of alternate interior angles. So the next thing is I'm going to look and see BG, and that's going to be congruent to GB. Again, BG going from 2 tick marks to none on this triangle. So BG is congruent to 2 tick marks to nothing on this triangle, GB. And that is because of the reflexive property. So we can now prove that triangle BGF is congruent to triangle GBC. And that is going to be because of the angle, angle, side theorem. I have an angle, and a side, and an angle, and a side. Therefore, we can prove that BC is congruent to GF, and this is because of CPCTC. And that is our proof. Finally, for number 8, we're going to answer the following questions given the fact that IG, so IG right here, is the midsegment of triangle EF. That should be an H. EFH. Sorry, talking about mistakes also, don't do F. Don't do F. All right, so what we know about a midsegment is that a midsegment consists of the midpoints of two sides. So we know I is the midpoint of EH and G is the midpoint of FH. We know it's parallel to the third side that it doesn't make. And we know that this length is half the length of this, or EF is twice the length of IG. So EI, they're asking, what is congruent to EI? Well, since I is the midpoint of EH, EI is going to be congruent to line segment IH. Same thing, so we know that's congruent to that. We also know this is going to be congruent to this. So when they ask for FG, what is FG congruent to? FG is going to be congruent to GH. Then it says if IG is 7, so we know this length is 7, what is the length of EF? Well, since IG is half the size of EF, 7 times 2 is 14, so EF must be a length of 14. Next it asks, is EI congruent to GH? Well, we don't have enough information to figure that out, so we're going to say no, but I'm going to be a little bit more specific and say not necessarily. There's one chance where it is congruent, and that is if we had an isosceles triangle and we know that this side is congruent to this side. Because if that were true, then these midpoints would all be, these sides, these parts, line segments, would be all congruent to each other because of these midpoints. Next, we're asked about angle HIG, so this angle right here. And we want to know, what is it congruent to? Well, remember that this triangle right here is a dilation of this big triangle. These are parallel, so that means that this has to be congruent to this because they are corresponding angles, and when you have parallel lines, corresponding angles are congruent. So angle HIG is going to be congruent to angle HEF. And again, you're going to skip F. And then the last question is EF parallel to IG? And the answer would be yes. Because IG is a midsegment, that property applies. So that's the end of our review packet. I know that there is one more sheet attached. You should look at the answer key to that for just some more practice and proofs.